Alrighty, in this video we're going to be looking at factorizing some quadratic equations. In particular, in this video we're going to be looking at monic quadratic equations, which is where the coefficient of x squared, or if this is the general term, the a value, when that's equal to 1, or in other words, there's no value here in front of the x squared. Well, there is, we just don't write it because it's 1. So the general strategy, okay, is we're going to be looking for two numbers that multiply to c. So I'm going to annotate here. We're looking for numbers that multiply to our c term and add to our b term. So they must both multiply to c and add to b. So my recommendation for the way we go about this is we start by, if we're given a quadratic equation here, we're going to start with the c term and we're going to find all of the factors of 48. So I'm going to write factors of 48, and we're just going to list them. We're going to say, well, we might make a list down this way. We've got 1 and 48, of course. We've got 2 and 24. We're going to have 3 and 16. We've got 4 and 12. 5 doesn't go into it. 6 does. 6 eighths are 48. We've got 7 doesn't go into it, and once we get to 8, we've already written 8, so we recognize that we've done all of the factors because we'd just be going back through this list now. So they're all the factors of 48, and if this is a nice, easy to factorize monic quadratic, it should be the case that a pair of these, whatever pair, adds to 16. So 1 and 48 obviously don't, 2 and 24 are too big, 3 and 16 is getting closer, but 16 is already there, so too big. 4 and 12, we identify that 4 and 12 both add to 16, and hence they're already factors of 48, and so that's the group that we're looking for. And what we're going to do is we're going to write that this thing is going to equal x plus 4 and also x plus 12. And that's as simple as that. I'm going to do another example that's just come to my mind. One of these is going to be negative, and I'm going to show you how to handle those situations now. All right, factorize x squared minus 17x minus 60. Now, I'm still going to employ the same process. I'm going to write factors of 60. Now, yes, I'm acknowledging that it's negative, but in the back of my mind, I'm keeping the idea that if it's negative and two numbers have multiplied to give it, then one has to be positive, one has to be negative, and I'll deal with that later. But first, I just want what the factors of 60 are. Now, there's a lot. This is one of my favorite numbers because it has so many factors, so we'll rip through them. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7 doesn't go into it, unfortunately. We're on a real roll there. 8 doesn't go into it either. Neither does 9, and we're back to 10, and hence that's it. All the factors of 60. We have 1, 2, 3, 4, 5, 6 pairs of factors that go into 60. And now we have to be a bit more clever with how we think about this. But the fact that this is a negative and not a positive means our two numbers aren't summing, well they are, but they're not really adding together to make 17, but rather they have a difference of 17. Because remember, if this is negative, one of those numbers has to be negative and one has to be positive, and hence we're going to have a difference of numbers that equals 17. So this is arguably just as easy, now that I think about it, to identify. The numbers with a difference of 17, nope, difference of 59, difference of 28, difference of 17, and we identify them. 3 and 20 are the pair. But there's one slight extra step here, because when I write down my brackets here, I'm going to write them just like this for a moment. I know because because my multiplication is negative, one of the numbers is positive, one is negative. So I'm going to put the plus first, the minus second. And to figure out which one of the 3 and the 20 is positive and which one's negative, we just have to think about this middle term. They have to have a difference of negative 17, and so for one to be negative, one to be positive, it has to be minus 20 plus 3, because we have to be negative, so the bigger number has to be the negative one. So 3 is positive, 20 is negative. That'll take a little bit getting used to if you haven't done it before, but you'll just trial and error both of them and you'll figure out which one it is. But a good rule of thumb is if the answer is negative, the bigger number has to be negative, which is our 20. And lastly, I have put up a new quadratic equation here. However, I've left the last number of 60 for convenience, so I can just use these factors again. But this time, our middle term is still negative, but the end term is positive. Now, the only way for that to occur is if both numbers are negative, because obviously when you sum two negatives together, you get a negative. But if two negatives multiply together, you actually do get that positive number at the end. So I know two of the numbers here are negative and they add to negative 32, and that is just going to be here 2 and 30. If you sum negative 2 minus 30 more, you get negative 32. So this one's even easier than the last one. We're going to get x minus 2 and x minus 30. And we can just double check by doing our FOIL expansion. X times x is x squared, minus 30x minus 2 more x gives us minus 32x. And lastly, minus 2 times minus 30 is positive 60 there. So those are the three scenarios you will face when you are expanding when you are factorizing monic quadratics. In the next video in this playlist, it'll be factorizing non-monic quadratics, and we're going to do that by a little thing called factorizing by grouping. See you there.